Hello everyone, I am walking through a review of polynomials. This is in the polynomial unit, getting to do lots of stuff with it, such as graphing, finding possible roots and actual zeros, things like that. And this is just a review of the entire unit, and this is it. Okay. So in this first problem, it says to use synthetic division to show that c is a zero given that the polynomial is a function. So basically, important things here. It's asking you synthetic division to show that it's a zero. It's always important to read the directions because a lot of people who just read synthetic division, they start doing synthetic division. But it is important to note that it's giving you a hint right here. It's saying to use synthetic division to show that it is a zero. Meaning if at the end you end up with something that is not a zero, you got it wrong and you should look again. So always read these things. It gives you hints sometimes. So the way synthetic division works is after the semicolon right here, it tells you that c is 5. So you're going to use synthetic division with the number 5. And that's the setup. You do a big L. You're going to have 3 lines here, 2 above the line and 1 below. So for spacing reasons, just make sure you're doing that. In this top row right here, you're going to write all of the coefficients. And it's very important to just double check that all of the coefficients are written down. Like here you have an x to the third, so you have to make sure you have all exponents less than 3. So like this is 3, this is 2, this is 1, this is 0. So there's no missing numbers. So now you can just write down the numbers in front. So 1, negative 10, 31, negative 30. And the process you're going to do is the first thing you do is you drop down this 1. And then you're just going to keep on over and over again. You're going to multiply and then add. And you'll multiply and add and multiply and add again. So this outside number 5 times 1 is 5. And then you add them. So negative 10 and 5 makes negative 5. Once again, you multiply. So 5 times negative 5 is negative 25. And after you multiply, you add. And that'll get you 6, and then 5 times 6 is 30, and then 30 and negative 30 makes 0. Boom. So sure enough, we have verified that it's a 0. As you saw a little bit ago, I forgot to put that minus sign for a second. If I forgot that minus sign, I would have gotten a big number and not gotten 0, so that would have told me I did something wrong. So I would recheck my work and see that I missed a negative sign there. So just make sure you're reading the whole thing, because it gives you hints sometimes. For the next one, it's saying c is negative 3, so we'll do the same thing. Boom, boom. We will double check all of the exponents. We have a 4, 3, 2, 1, 0, so nothing is missing. So I can write the numbers 2, 7, 5, 7, 3. Okay. And we'll continue to do this. I suggest you guys pause the video, put this on a separate sheet of paper, or if you have this review guide, do it on there. Try to see if you can get it first, and then, unpause the video and come back. But that is my suggestion. Pause, try it, and unpause. What you do is you drop down the 2, and then once again you multiply to get negative 6, and then you add to get 1. So multiply, add, multiply, add, multiply, add, and we should get 0 here. So let's keep going. Negative 3 times 1. Add, multiply, add, multiply. And sure enough, once again, we get 0. Okay. So this is just synthetic division. Later on this review, we get to doing things where you have to actually do something with it. Like I said, this is verifying. As soon as we do this, we have verified end of question, no more. But later on, you'll see that we're going to use these numbers to do 1x squared minus 5x plus 6, or at least use the quadratic formula with this a, b, and c. But for now, we're just done. So let's go on to the next one. Here it says to graph the polynomial, as long as also telling all of this other information. It's important to note that for these first three, it is not actually asking for anything on the graph. It's all talking about possibilities. These are possible roots. This is the maximum positive roots, the maximum negative roots, implying that it could be less than whatever number you end up putting here, because it's the maximum, but it could be less. So all of these are just possibilities, which means you can't just graph it and get the answer. Unlike zeros and multiplicities, those you can just look at a graph and say, oh yeah, those are the zeros and multiplicities. And behavior, oh yeah, it's pointing this way and that way, that's the end behavior. Relative mins and maxes, you have to use calculus or calculators for. We are using calculators for. But these ones you have to memorize the thing that you're supposed to do. And the big vocab here is positive roots, negative roots, and possible roots. Those are the key words that you're like, oh yeah, I'm reading this possible. Possible is going to be implying I do the P over Q thing. Positive and negative, that's Descartes' rule that we're going to be doing, rule of sign changes. His name is Descartes. It's spelled Descartes if you're looking through your notes, but it is pronounced Descartes, because believe it or not, he is not from America, so you don't pronounce his name as if you were American. So Descartes, but in your note. Actually, I think there's also an S there. But anyways, it is a rule of sign changes. And what you do for that, let's change colors, is you look to see what is positive and what's negative. Okay, so this first one is negative. The second one is positive. The next one is negative. And the next one is positive. And you look to see how many times it changes from positive to negative or negative to positive. Like this first one's negative and then it turns positive. So it changed. It changed from negative to positive. This one was positive and now it's a negative. So once again, it changed. It changed from positive to negative. And then it changed back from negative to positive. Which means it changed positive, negative 1, 2, 3 times. So the max positive amount of roots is 3. It could be less than 3, but the maximum amount is 3. To do the negative amount of roots, you have to do this weird thing where short story is any odd exponents, you will change the sign in front. And then you recount how many times. So you do the same thing as positive, it's just sometimes these will change. Like this exponent is 3, so instead of negative, it will be positive. This is x squared, that's even. Because it's even, you don't need to change it. So it'll be positive still. This is an x to the first, which means it's odd, so you do have to change this negative to a positive. And there's no x here, and if there's no x, that just means there's 0 x's. So once again, that's even, so it's going to stay a plus. So all of the odd exponents changed. And now if you count the whole how many times does it change positive to negative, well, positive, it stayed positive. It stayed positive. And then, just like me, it stays positive. Yay! Which means it actually never changed sign. So there are 0 negative roots, 100% facts. Okay. Possible roots. This was known as the P over Q thing, where P is 30. It's the very last number called the constant. And Q is the number in front, which is just a 1. It's technically a negative 1, but we don't care about that because with possible roots, all of them are going to be plus or minus anyway. So saying 1 versus negative 1 is just kind of irrelevant to the situation. The next thing you do is you take all of the factors of 30, so literally everything that goes into 30, and divide it by everything that goes into 1. Luckily, the only thing that goes into 1 is 1. So you would have like 1 goes into 30, 2 goes into 30, 3 goes into 30, 4 does not, 5 goes into 30, 6 does, 7 does not, 8 does not, 9 does not, 10 does. And from here they're just kind of pairing. So like 5 and 6 was 30, 3 and 10 was 30, 2 and 15, and then 1 and 30. And I did not plan that very well. You would divide all of these by the factors of 1, which is just 1, and you just get those numbers. So 1, 2, 3, 5, 6, 10, 15, 30, 10, 15, 30. And as I said, all of them plus or minus. Boom. Those are the possible roots. These are not actual roots. We're about to graph them, and you will see it does not actually go through those numbers. So you will grab your calculator, you will go here, and we will write down negative x to the third plus 10x squared minus 31x plus 30, graph. Okay. And what you're looking for is to see if it goes through anything obvious. And yeah, it's definitely going through some obvious numbers here. So like this is 1, this is 2. So it's going through 2, it's going through 3, not 4, but 5. So 2, 3, and 5. 2, 3, and 5. Sure enough, 2, 3, and 5, those were on our possible roots, and they work out just fine. It's important to note, I suppose, that this is possible rational roots, meaning fraction or whole numbers. It could technically be a 0, that's a decimal, that's not rational, but we're not talking about that right now. So those are the zeros, and I'm just going to kind of copy paste some of this stuff at least. We said it was 2, 3, and 5, like so. And it's gonna kind of swoosh down like that and do stuff. Which, at least looking at this, I can tell that my end behavior on the left, it looks like it's going up to positive infinity, and on the other side it's going down to negative infinity. Video's gotten to be over 12 minutes, so I'll do the relative max and mins and finish the rest of it on the next video and continue on. So part 1 done.